All right, let's start with part 2 of conditional operators in C programming. And we're going to talk about logical operators and bitwise operators. So let's talk about logic operators first. So I'm pretty sure you've heard of logic before. Logic is basically when you are evaluating a statement or an expression and determining whether or not it is true or false, right? So in C programming, we have these 3 logical operators. We have the AND operator, the OR operator, and the NOT operator. And basically, the way they work is this, okay? So say you have the AND operator, which are these 2 ampersand symbols, okay? Both conditions of an AND operation have to be true in order for the expression to be true. So let's look at an example. We've set A equal to 7. We've assigned 7 to B, and we've assigned 8 to variable C. Okay, so these are the expressions. The expressions are always going to be in parentheses. Okay, so the expression is A equal B and C greater than 5. So we have to evaluate each expression, and each expression or condition, we call these conditions as well, condition has to be true in order for the entire AND operation to evaluate as true. All right, so let's look and see what's going on. A equal to B. Well, A is equal to 7, so that's true. So that's a 1, because that's true. Okay. Then we go to the next condition or expression, C greater than 5. C is equal to 8, so C is indeed greater than 5. So that's true, right? So both are true. So this expression would evaluate to 1 or true. That's what that would equal, okay? Let's look at the next example. A equal to B. Well, we already said A was equal to B, so that's true, right? C and C is less than 5. Well, C is 8. It is greater than 5. So that's a 0. Well, because both conditions are not true, this expression is going to evaluate to false, which is a 0. So that's how the AND operation works. Now let's look at the OR operation. For an OR operation, one of the conditions of the operation has to be true in order for the expression to be true. Only one does. All right, so once again, we have assigned 7 to A, 7 to B, and 8 to C. A equals B, that's true. That's true, that's a 1. Or C less than B. C is 8, B is 7. C is not less than B. So that's false, but because one of these conditions is true, this expression evaluates to a 1. Okay. Let's look at the next example. A not equal to B or C is less than B. A is not equal to B. Well, we already know that is false, right? Because they are equal. So that's false. Or C is less than B. Well, we know C is greater than B. So that's false too. So the OR expression evaluates to 0 or false. All right. Next we have the NOT operation. How does that work? The way the NOT operation works is that the expression evaluates to the opposite value of the operand. Okay, so in this example, all right, the operand is going to be within the parentheses Okay, so once again, 7 has been assigned to A and to B, and 8 has been assigned to C. All right, so we go inside and we say A is not equal to B. Well, that's false, right? So that would be a 0. But then we want to take the complement, or we want to knot that 0. So then that evaluates to a 1. So this expression would evaluate to a 1. All right, let's look at the next example. Not A greater than C. All right, so A is 7, C is 8. A is not greater than C, right? So inside here evaluates to a 0. Then we take the complement of that, or we knot that. So a 0 evaluates to a 1. So that would be a 1 as well. That expression would evaluate to a 1. All right, order of operations. So you've heard of this before in algebra. Remember PEMDAS. Please excuse my dear Aunt Sally. And basically, it instructs us on how we go about solving a complex expression. All right, so P tells us that the first thing we evaluate are parentheses. Next, exponents. Next, multiplication or division, depending on which one we get to first. And then finally, addition or subtraction, depending on which one we get to first. So there is an order of operations in relational and logical operators as well. The highest order is the not. Next we have greater than or equal to, less than or equal to. Next we have equal or not equal, and finally we have and or. Okay, so that is the order in which you would solve your expression. So let's evaluate this expression that we have beneath us. Not 0 and it with not 0. Okay, so how do we go about evaluating that expression? Well, we already said the not is the highest order, right? So we do that first. So not 0 is a 1. We carry down our ampersands, right? And then we have 2 not. So we go to the inner one first. So we carry 1 down. Not 0 is 1. So now our new expression is 1 and it with not 1. Okay? Well, we bring down our 1, our ampersand. Not 1 is 0. So we end up with 1 and it with 0. Well, that's going to equal 0 because remember, anything and it with 0 is 0. Let's look at the next example. We have not 0 and it with 0 or 0. Well, parentheses always come first, no matter what type of expression you're evaluating. So first we look inside the parentheses, then we'll go to the not, then we'll go to the or. So 0 and it with 0 is 0. So we have not 0 or 0. Not 0 is 1. So we have 1 or 0. Remember, 1 ORed with anything is 1. So our expression evaluates to 1. All right, let's look at this program that uses relational operators and see what's going to happen. Okay, so I'm going to open it up in code blocks. So here it is in code blocks. Let's see if we can make it larger so it's easy to see. Okay, so what's it going to do? Well, first of all, we're going to declare x and y as integers. We're going to assign 100 as the value of x. For y, we're going to assign the value that this expression evaluates to. Okay, x greater than 10. Well, is x greater than 10? X is 100. Definitely 100 is greater than 10. So that should evaluate to true. So y should equal 1 after we run the program. So let's run it and see. All right, so here we go. And yes, indeed, it says y is equal to 1. So that is how relational operators work in your program. Close that out. All right, next up we have bitwise operators. So these operators operate on bits. So you have the bitwise and, the bitwise or, the bitwise exclusive or, the bitwise not or complement, the bitwise shift right, and shift left. All right, so first of all, let's talk about what bits are. So to compare it to something else you're very familiar with, think about the decimal number system. How many digits do you have in a decimal number system? You have 10, right? From 0 to 9. Those are the digits we have. So my question that I have here is, how far up from 0 can you count with 2 digits? So if you have 2 digits to make up your number, that means you can go from 10 to 99, right, in decimal. Then if you were going to go to 100, you would need 3 digits, right? If you were going to go to 1,000, you would need 4 digits. So we combine digits to make numbers in the binary system. We're going to do the same thing in the binary system, okay? So what are bits? Bits are basically binary digits. So that's what they are. And in the binary number system, there are 2 digits, 0 and 1. That's it. So how many bits is a byte? I'm pretty sure you've heard of gigabytes, terabytes, kilobytes. What is a byte? So traditionally, a byte is 8 bits and a word is 16 bits. And that word comes from what is the size that the CPU can process. What size data can the CPU process? It used to be 16, but now CPUs are more advanced, and there are 32-bit CPUs and 64-bit CPUs. So in those cases, the 32-bit CPU, their word would be as 32 bits, and in the 64-bit CPU, the word would be 64 bits. But traditionally, we say 16 because that's pretty much how it started out. All right. So let's count to 8 in binary with an 8-bit word. Okay, so we start out with all zeros. Then we go to 1. Then we go to 2. Then we go to 3. Then for 4, we need another digit. All right. And then for 5, 1, 0, 1. For 6, 1, 1, 0. For 7, 1, 1, 1. And for 8, we need another digit, right? But because these are 8 bits, we're going to add zeros that come before our more significant bits. And just like in the decimal system, they don't add anything to the value if they precede a number. I think I'm missing one here. There's some zeros all the way down. I was missing 1 bit. Okay, so that's how you count to 8 in binary. And we are right at 14 minutes, so we're going to have to stop this video right here, and then we will continue on with part 3.